Hello, and welcome back to the course on thermodynamics. We are now on Unit 3, which is all about the first law of thermodynamics. So in the previous lessons, we have discussed about the thermal properties of matter, such as the molecular kinetic energy, the molecular root mean square speeds. And for this lesson, we will be introducing the unit on first law of thermodynamics, and we will first discuss what is a thermodynamic system and how is it related to the thermodynamic state variables that we have discussed in the previous unit. So what is a thermodynamic system? So it's basically any collection of objects that is convenient to regard as one unit and has the potential to exchange energy with its surroundings. So our bodies are examples of thermodynamic systems. A rocket is a thermodynamic system, or anything that has the uh, potential or ability to exchange energy with the surroundings or environment. So a thermodynamic process is a process where there are changes in the state variables of the thermodynamic system. So the pressure, the volume, or the temperature of the system may change. So from here on, when I say system, I mean a thermodynamic system. So in this example, our thermodynamic system here is just the popcorn. Take note, you in a thermodynamic system is defined by the exchange of energy, and you have to also define the materials or the objects that are members of your defined thermodynamic system, and you also have to define which are not members of your thermodynamic system. So in this example, our thermodynamic system is the popcorn. It doesn't include the pot, it doesn't include the lid, so only the popcorn inside the pot. That is our thermodynamic system. Now, in the thermodynamic process shown here, heat is added to the system. So you have heat heating the pot, and in turn, it heats the popcorn. And because of that, the system, which is the popcorn, does work on the surroundings. So the surroundings can mean any object in contact with your system. So it does work on the pot, in this case, to lift the lid of the pot. So it's actually lifting the lid of the pot. It's doing work because it has absorbed heat. What happens actually here is its volume expands. So its volume increases or changes or expands, and lifting the lid up. So this is an example of a thermodynamic process called change in volume or volume change. So in this process, actually both the temperature and the volume changes, but the pressure is still atmospheric pressure. In contrast to pressure cooking, if you have a pressure cooker, it's actually a closed thermodynamic system. Uh, in this process called pressure cooking, the temperature and the pressure actually changes. And in this case, the volume is fixed or the volume is constant. So the pot doesn't expand, but the pressure inside the cooker increases with temperature. So again, a thermodynamic system has the ability to exchange energy with its surroundings or environment, and it can do this by means of heat or work or both. So we need to again review the signs for heat and work uh, in physics and specifically in thermodynamics, but it's actually just the same, it's generic. So if you have a positive heat, positive value of Q, this means that heat is absorbed or the heat is entering your thermodynamic system. If you have a negative heat, this means that heat is released or heat is leaving the system. If you have a positive work, meaning work is done by the system on the surroundings. So in the case of the popcorn is actually doing work. It's actually doing work on the lid of the pot. It's actually doing work on the surroundings. So the work is done by the popcorn on the surroundings. If you have a negative work, this means that work is done on the system by the surroundings. So again, the surroundings can mean any objects in contact with your system. So the air, for instance, the surrounding air, for instance, uh, can be designated as your surroundings. Okay. So for example, this is your thermodynamic system. So if it absorbs heat, so Q is greater than 0 or positive, it means heat is entering the system. And if it's doing work, the system is the one doing work, then the work is positive. Work is done by the system. In the case if the system, say, work is done on the system, usually what happens is if work is done on the system usually releases heat. So those are the basic uh, heat and work mechanisms on a thermodynamic system. So it absorbs heat, it does work, or work is done on the system, and uh, the system releases heat. So those are the basic work and heat mechanisms in a thermodynamic system. So a rocket is an example of a thermodynamic system. It uses heat of combustion of its fuel. So it burns its fuel. And when burning its fuel, it's actually absorbing heat. And in turn, it does work on its surroundings. So in the case, the surroundings here is the surrounding air. It does work on its surroundings. So there's a work done by the rocket. And this work done, it pushes the air below it, and by virtue of Newton's third law of motion, the air will also push it upwards in the opposite direction. So it will propel the rocket upwards. So another example is a car also uses the heat of combustion to do work. Uh, it actually converts heat of combustion to rotational kinetic energy to rotate the wheels of the car, and in turn moves the car forward or backwards. So we will discuss more of this when we go to the topic on engines. So we'll discuss more about how the car operates, how the engine of the car operates on the next unit, the unit on second law of thermodynamics. So that is it for this lesson. So we will continue our discussion on Unit 3 in the next lesson. So goodbye.